Actually, Ryan reminded me of the story I wanted to tell, a wildlife story. I sent one of my undergrads out to take rye samples, or cereal rye samples, in one of my cover crop plots, and she came back and said there were all these divots all over the rye field. And I said, what do you mean, divots? And she said, there's like these little depressions in the soil, and the rye is really short. And so I went out there with her the next time and looked, and there were just hundreds of deer tracks. The rye was grazed down to, about little nubbins, and I said, well, our biomass measurements are going to be a little low this fall. We've worked mostly with cereal rye and spring oats. Not necessarily because I think they're the best cover crops or the only cover crops that you can use, but at least with the case of cereal rye, I've never had a failure getting cereal rye established. I've always gotten some growth every year, and for the kind of environmental studies we've done, consistency is important, I guess. And this is just a shot of an NRCS demonstration from northeastern Iowa showing cereal rye in corn silage ground. And, as we heard the farmers this morning, they have lots of ideas on how to execute, how to establish cover crops, how to get them going on their farms. And I think as scientists, we should provide more of the principles or the big pictures of what are the understanding or what are the reasons that these things might work. And at least this is the way that I look at cover crops, that we've taken an agricultural system and inserted it into what used to be prairies in Iowa or savanna. And we've gone from having plants on the landscape all year round to now only having plants at most 5 months of the year. And probably of those 5 months, they aren't alive for all 5 of those months, or they're very small. And why that's a problem is because, at least in Iowa, we get a lot of our moisture and a lot of our drainage or water moving through the soil from about the 1st of March to the 1st of June. And then after June 1st or sometime around June 15th, the corn or soybean crop starts to use more water than we have moving through the soil profile. Also, as we've heard earlier today, we aren't taking advantage of the warmer temperatures we sometimes have in the fall, the sunlight, so we're not replenishing organic matter. Jim will talk about phosphorus more. I'll mention some of the effects on erosion and nitrogen. When we first started working on cover crops, it was to look at erosion following soybeans in the days when we had conservation compliance. That changed because they changed the rules for conservation compliance, but we went ahead and still kept working with cover crops. And these were some simulated, or I guess rainfall simulation measurements that we made over 3 years in the middle of April on a no-till soybean field with about a 5% slope. The far left picture is no-till without a cover crop. The middle picture is where we had an oat cover crop in the fall, and it winter killed, so you can't see it. And then on the right, with the rye cover crop. We made 2 kinds of measurements here. We looked at sheet erosion, or the erosion caused by raindrop impacts, and then we also looked at rill erosion, or the erosion we get from water flowing across the surface. I think the biggest revelation we had was that on the far left, that one of the things that the cover crop did is it prevented the residue, soybean residue, from moving when we started to get water flowing across the surface. And that made a big difference, especially for rill erosion. We still had some raindrop or sheet erosion, but the biggest impact was rill erosion. With the oat cover crop, you can see just at the bottom the residue started to move. And with the rye cover crop, there was almost no erosion. Over a year basis, we would calculate that that was about the difference between 2 tons per acre per year for the no-till versus about 0.9 tons per acre. So about a 50% reduction. And that's kind of what our measurements showed. We split it into inter-rill erosion or raindrop erosion and rill erosion, which is from flowing water. The green bar is from the oat cover crop. And we were actually surprised at how well the oat cover crop, which winter kills, helped to prevent erosion. And then our rye cover crop, especially with rill erosion, had a big benefit, almost 90% reduction in rill erosion. And mainly because it kept the residue from moving. Now, this is a shot that farmer Steve Berger, who's at this conference, sent to me. This is from Google Earth. I don't know what possessed him to look at Google Earth after this rainstorm went through. He had a 4.5-inch rain overnight. The field at the top that's kind of green, and this is in the middle of April, is his field. There was no-till soybeans. You see he's also got terraces, which is good and would help a lot in this situation. His neighbor is also a good conservation farmer, no-till. He does have waterways in a lot of the places which are really vanishing in Iowa. A lot of farmers don't even have waterways anymore. And yet, even though he was in no-till and had good soybean residue cover, when he had that 4-inch rain that came in a very short period of time, it overwhelmed his no-till. It started to move residue, and he developed these big rills, which Steve assures me weren't there the week before. We heard one of the speakers this morning talking about having an 8-inch rain overnight. There was a town in Iowa that had 2 8-inch rains within a 1-month period. So we maybe always had these kind of things, maybe not, but we certainly are noticing them more. And there are at least situations where no-till won't prevent this kind of erosion. The other thing we've done quite a bit of work with is nitrate loss in tile drainage in what we call the Des Moines lobe in Iowa, which is it's about the north-central 1/3 of the state. It's a very big area, highly productive soils, but wouldn't be farmed if we didn't have tile drainage. At least they weren't when Iowa was first settled. This is just a shot of our plots. We have 24 plots here. We first put the tiles in 1999 and got things settled down to start this experiment in about 2002. And for each of the 24 tiles, we collect the water that comes from each tile and then measure the amount of flow and also the nitrate concentration. So we take flow times concentration and we can calculate load, or how much nitrate is flowing through the tiles. And that's just a shot of a rye cover crop in the middle of April. And we drilled that in. First, I wanted to just show you a little bit about the tile drainage over those 12 years. This last column is our average. The clear bars are the rainfall in those years. The red dotted line is, and I used a 100-year average rainfall at this location. The red bars are the rye cover crop plots, and the blue bars are the corn-soybean rotation without a rye cover crop. I guess one of the main things to show you is that we had 2 years, 2008 and 2010, that were the had the second and third highest rainfall totals in those 100 years. The number one year was 1993. We've had some other top 10 years in the last 20 years also. So those were big events. The other thing is that other than a few years, maybe 2011, maybe these 2 years, the red bars are really not much different than the blue bars. We haven't completely figured that all out yet, but on average, the red bar, which is the rye cover crop treatment, only has about 1.5 inches less drainage than the plots without cover crops. So the cover crop is not changing the amount of water coming through the tile that much at this location. It might in other places. It might be just because we had some really wet years in there too. We certainly, well, these years got dry in late summer, but not in the period of time when we had drainage. Then I'm showing this graph is nitrate concentration. It's in milligrams of nitrogen per liter, but that's the same as parts per million. So we'd like to have water below 10 parts per million. We did. Here the blue bars again are without a cover crop. These 3 years in here were below that 10 parts per million anyway. But remember, we had those high rainfall years in 2008 and 2010. And actually this 4-year period from 2007 through 2010 were the wettest 4-year period we've had in the 100-year rainfall cycle. So what we think one reason the nitrate levels came down here is because we've had so much water flowing through the soil that we kind of leached things out. Then here you see 2011 was a little bit drier, at least late in the summer. And then 2012 and 2013, the nitrate levels are starting to come up again. I guess the bottom line is that the cover crop over those years, I should also say that the even number years are corn years, and the odd number years are soybean years. And there was no nitrogen fertilizer applied in any of the odd numbered years. All of the fertilizer was applied in the even numbered years. And we applied our fertilizer at planting for corn and then at side dressing. So in a split application. So in any case, we're seeing a substantial reduction in concentration. And then when we calculate the load, or took concentration times the amount of flow, and that's kilograms per hectare, but that works out to about 1 pound per acre. I think it's 1.1 or something. Here our big loss year was 2003. That was a soybean year. In that year, we know that we had residual fertilizer because the end of 2002 was quite dry, so our corn yield was a lot lower. But here in 2007, I know 2006 was 225 bushel corn, and so it wasn't a low yielding year, and there really wasn't that much residual fertilizer. We take fall soil samples every year, so we know there wasn't a lot of residual nitrogen there. I think we'll see some of the other data. Other people show that when we have warm falls, we get mineralization of soil nitrogen or decomposition of residues, combination of all of those things, and then we can lose, the actual losses occur in the following spring when we get that flush of water through the soil. So the amount of load that we get in individual years depends on the concentration and then how much water is going through the profile. In 2011 and 2012, we had low concentrations and lower amounts of drainage. So we didn't get much going through. Here they're starting to come up again in 2013. So I sum that over the 9-year period. The corn soybean without a, or I'm sorry, 12-year period, without a cover crop lost 480 kilograms per hectare, or about 500 pounds of nitrogen. The corn soybean with rye lost about half that, for a total reduction of about 55%. So did the rye take up enough nitrogen to account for that reduction? And the answer is yeah. We took our cover crop biomass samples, so 1.7 megagrams, that's about 1,700 pounds per acre. And we were taking up about, it had about a 2.86% nitrogen concentration, so about 42 pounds of nitrogen per acre, or over the 12-year period, 512 pounds of nitrogen. So the cover crop took up plenty of nitrogen. And the big question is, what's happened to all that nitrogen? So at least for the first 4 years, Dan Janes did a nitrogen balance, and we know how much fertilizer was added. We estimated how much nitrogen fixation by soybeans. We did some N15 measurements to help us with that. We did nitrogen in the rainwater. We know what came off the field in grain. We know how much was lost in the drainage water. We measured the change in inorganic nitrogen. It's really hard to measure the change in organic nitrogen, or what's still in organic matter. We did measure nitrous oxide losses, but that isn't all the gaseous losses. I guess the bottom line comes down to is that with the corn, soybean, with rye cover crop over 4 years, the first 4 years, we gained 82 kilograms or 82 pounds of nitrogen per acre. In the corn, soybean without the cover crop, our nitrogen in the soil, or that system, went down. So you'd think if we would have continued at that same system, our nitrogen in the soil is going to decrease over time. And Dan has done those measurements on other plots or other experiments and come to the same conclusion, that we're losing soil nitrogen in our normal corn-soybean rotation. He's also done experiments where he has fertilized at different rates and looked at the loss of nitrogen in tile drainage. And here again, he's putting on his nitrogen at planting or after planting. And even at nitrogen rates that reduce corn yield, we still lose substantial amounts of nitrogen in tile drainage, depending on the year, when rainfall comes, you know, all those things. So we've got a lot of research questions. So where is that nitrogen going? Can we reduce fertilizer rates in the future if we keep cover crops going on these plots? I think so. How much is the big question, but we could work in that direction. Will nitrogen losses in drainage increase after we've had them there for many years? I don't think so, as long as we keep growing them. We know that if we add a little bit of nitrogen fertilizer to them, they grow a lot more, so that means they haven't reached capacity. They're nitrogen limited, at least I think. And then do soybeans fix more or less nitrogen when they're following a rye or an oat cover crop which has reduced soil nitrogen levels to a low level? I don't know the answers to those questions. I just wanted to show you, though, that mine aren't the only results. These are 4 other sites in Iowa where they've had cover crops and nitrogen measurements in tile drainage. These are based on concentration. Nashua, Iowa, and Gilmore City are Matt Helmer's experiments. They're farther north than Ames, and they're remote locations for Matt, coming out of Ames. And they've gotten a lot less than the 55% that I showed. But normally their growth of their rye cover crop is a lot less than what we have. The Cobb's experiment, which is near Ames, Iowa, Kelly, Iowa, is about 15 miles south of Ames. A higher reduction there. And then the Tim Smith farm, which comes from Eileen's data. And he's in Eagle Grove, Iowa, which is about an hour north of Ames. And in a farmer's field, monitoring the tile drainage coming out of his field, he got a pretty nice reduction compared to the water in the creek that the tile drained into. So results will vary, but I would expect they would vary. It depends on how much cover crop growth you're going to get. It's got to grow in order for it to have an effect. You're going to have different weather at the sites. We're going to have some years where we aren't going to have much drainage, so there's not going to be a big effect. And some of these other sites were drier than Ames. Different soil types, so if you've got lower organic matter content, you're going to probably lose, well, I don't know if that's totally true, but you lose less from the organic matter. You might lose more from the fertilizer. Tile spacing, tile depth, how effective the tile, how quickly the tile removes water from the soil is going to have a big impact. It could go plus or negative in terms of the cover crop's impact. They're going to have different crop management or a different field history. We think that the field that we're on near Ames, since it's near a livestock facility, we think at one point in the past it was probably manured. So it probably has higher organic content. So winter crops reduce nitrogen losses by taking up nitrogen and reducing nitrate concentrations in the soil. We didn't see a very big impact on the amount of drainage that comes out, but I know one of those other sites that I talked about, they did show a reduction in drainage when they had cover crops. And the impact of cover crops on nitrate losses depends on the growth of the cover crop, probably more than anything, the soil type, weather, and when the drainage occurs.